Perfect. Thank you guys so much for your time and thank you for joining us today. My name is Fatima, super excited to be here. And I also have my colleague on the call who's an expert in the field. So I'll just allow him to introduce himself. And then what we'll do is I'll go over some high level concept when it comes to infrastructure for AI deployment. And then my colleague who works on AI infrastructure, he will give some use cases. So I'll just pass over the mic to Torian so he can introduce himself. So Torian, over to you.
Hey, good morning. My name is Torian Dyer. I am a senior technical product manager and AI infrastructure. I focus on data science.
So thank you so much for having us, DSN team. So today, essentially, what we'll be doing is we'll be doing a high level overview of the system level designs to networking and what it looks like when you need CPUs or GPUs. And then we'll talk a little bit about the infrastructure from a high level. Again, if those on the call can mute themselves, that would be fantastic. Awesome. Thank you very much. Um, So this slide, let's talk a little bit about how an organization can get started with generative AI. Generative AI is a field that we've spoken about a lot with the DSN community, so I thought it would be important to touch on it again. So the line of business identifies the opportunities they have to generate revenue or to make things more efficient. If they don't do that, then their competitors will. So AI and ML is the next way of doing things. And the LOB knows that they need AI in order to make a substantial business impact. Generative AI isn't just a single person's responsibility, it's a responsibility of a multidisciplinary team. And I know that DSN has different personas. So you have to bring together the core IT, the application developers, and the line of the business to conceptualize this. Essentially, the program will eventually adhere to your company's IT compliance and regulatory needs. After we have our key stakeholders, the line of business and the application team analyzes data for training and customization purposes. Core IT via NGC catalog is then able to provide the foundation to build data intensive foundation models or essentially customize existing ones. All of this can be done on NVIDIA certified hardware, which means the right infrastructure will enable efficient and effective deployment of our AI solutions. Finally, but most critically, we need to develop a plan for responsible AI. Earlier this year, our colleague Michael Boone spoke about responsible AI to the DSN community. And in Michael's session on responsible AI, he talked about leveraging tools and best practices to ensure that our AI models and applications uphold ethical standards and operates responsibly. Basically, deploying generative AI in your organization is not just about the technology, but it's also about making sure the technology aligns with your business goals, your team's capabilities, the strategies you have around data, and the infrastructure readiness that is at your disposal. And all of this will essentially allow you to deploy generative AI. Now, if we go on to the next slide, we'll talk about some of the requirements for customizing, let's say, LLMs. So at NVIDIA, we're equipped to provide solutions to three critical components for customizing your own generative AI. So for accelerated compute, for example, we have the DGX and we have the DGX Cloud specifically designed for LLM training. For those customers who already have their data in the cloud, we've established partnerships with various cloud service providers. And later on, Torian will talk a little bit about our cloud service providers and some of the differences within them. Furthermore, our infrastructure can also run seamlessly on platforms provided by our infrastructure partners. So in terms of the necessary software stack for training and inferencing in language generative AI, we have NEMO software stack. And we've spoken about NEMO a few times with the DSN community. I'm sure several of you are aware of a startup called Intron Health, which is a Nigerian startup. For those of you that aren't aware of Intron Health, essentially what Intron Health does is they do automatic speech recognition, but for Nigerian accents, and it's created for doctors so that doctors are able to jot down voice notes and have those voice notes transcribed into text. The issue that they were trying to solve for was African accents with English. So they did over accents. And in order to do that, they use our Nemo software stack. We also have BioNemo, and BioNemo is more for biological sector. So it's more for like the biosciences and the healthcare. And then we have Picasso. And Picasso is more so focused on image task, like image task generation. So now we'll talk a little bit about NVIDIA AI Enterprise. So it might not be so relevant to the developers here, but it is good to think about if you're thinking of going into different enterprises. Speaking of enterprises, recently I saw that Deloitte, for example, the one in Nigeria, is currently hiring for AI engineers with some experience in enterprise. And that's why certain NVIDIA technology is super helpful. So if you can go on to the next slide, that would be great, please. So many of you might testify on this call that, the learning curve to AI is quite steep and AI itself can be extremely hard. And because it's hard, NVIDIA has tools to help you with deployment. And these tools include pre-trained models to larger IT ecosystem, but NVIDIA AI Enterprise specifically has tools that can help you speed up your development. So we'll take a look at an overview from the bottom up, and then we'll go through every single block that we have on the screen. As you can see, as we mentioned before, whether you're doing AI in speech, in conversational AI, customer service, autonomous AI, or robotics, we've developed different toolkits for every single one of these verticals. If we can go on to the next slide, that would be great, please. Thank you. So as I mentioned before, we have different software stacks that is geared to satisfy specific personas or specific groups. So for an example, when customers have responsibilities like data center architect, support engineers, and etc., things like infrastructure and infrastructure management and operations are things that are extremely important to them because it's now their responsibility to provide the necessary equipment in the data center, which can be used to satisfy a line of business requirement. Similarly, data scientists, which I know there is several of them in this community, and application developers are data science personas that realistically have no inclination to understand the underlying hardware. These groups are notorious for shadow IT, where they can spin up cloud instances using C to do their AI and ML work simply because of core IT doesn't have the resources. At the end of the day, NVIDIA AI Enterprise is a toolkit enabling a symbiotic relationship between core IT personas and data science personas. And this is how we get there. So today I will talk a little bit more on the enterprise side, and then later on, Torian, our resident expert, will talk a little bit more about it from a data science perspective. If you can go on to the next slide, that would be great. Awesome. So here we have NVIDIA's AI Enterprise, and it showcases how it can be deployed in just about any data center, enabling IT to deploy AI workloads and infrastructure that they're already familiar with. So when we say that NVIDIA Enterprise can run anywhere, we enable AI workloads to run in public, private clouds, edge, and on-prem. If enterprises choose, they can run AI workload in any combination that they see fit. So for an example, majority of enterprise VMware or OpenShift, NVIDIA AI Enterprise runs on VMware, on NVIDIA, and VM certified hardware. With OpenShift, we support in both bare metal and VM vSphere virtualized environments, which is important to note because a lot of enterprise customers are deploying OpenShift on VMs. But we also support upstream Kubernetes And if a customer wants to just run containers, we can also support that deployment scenario. If we go on to the next slide, we'll be able to see some of the different systems. So NVIDIA AI Enterprise runs on NVIDIA certified systems available from our OEM partners. An NVIDIA certified system brings together NVIDIA's GPUs and networking onto systems from OEM partners. OEMs that are familiar with the enterprises that we work with. This conforms to NVIDIA's design of best practices and has passed a set of tests validated by the best configuration and performance best practices. With certified systems, enterprises can confidently choose performance-optimized hardware solutions backed by enterprise-grade support to securely and optimally run their accelerated computing workload, both in smaller configuration and at scale. NVIDIA AI Enterprise is also certified to run on several data centers, including, and the GPUs that they include are A30, A100, and most recently available are the H100. And the NVIDIA H100 GPUs are built on the NVIDIA Hopper architecture and now includes the AI Enterprise software as well. And then in the next slide, we can see some of the different systems that are used for our underground infrastructure. So if we can move on to a few slides, that would be great.
Oh, okay.
Yes. Can we move on to the DGX, please? And then we'll just talk a little bit about the DGX. If we can move on one more slide. If we can go to slide 14, that would be fantastic. So 3 more slides, please. And 1 more slide. Awesome. So now we'll talk a little bit about the DGX system. And the reason why we want to focus some time on the DGX system is because when we're talking about the African ecosystem, the DGX is what we're seeing being used a lot by different organizations. So we'll introduce what the DGX is, and after introducing it, I'll share with some use cases of universities in Tunisia, for example, who are using the DGX and what they're using it for. If we can go on to the next slide, that'd be great. So it would be great as well to know in the chat or from the room how many folks have heard from the DGX. But when we think of the DGX, we often think of it as a server. But instead of simplifying what a DGX is, let's look at the overall platform ecosystem. So this can be consumed in whatever fashion your customer likes. So if your customer needs on-prem solution, you can choose a DGX H100. If they need data center scale, you can choose a DGX base pod. And if they need a turnkey supercomputing data center or that mimics NVIDIA's own infrastructure, they can choose DGX SuperPod. If they need something smaller, they can just get the standard DGX. So in Tunisia, for example, we are working with a university called ISPRI, and ISPRI has a DGX at their university that they provide for their researchers to be able to do more advanced labs. Then there's also a DGX in another organization in Tunisia called Innovation City, and it's an accelerator. And currently that DGX is being used by startups, by lecturers, and by students in order to bring their MVP into reality. So the DGX just shows you how flexible it is and that it's already in use on the continent. Now, if you can go on to the next slide, that would be great. As we've mentioned several times when we've spoken about AI infrastructure and how to think about it, we have to think about it beyond hardware. And the DGX isn't just hardware. It's a combination of hardware and software, bringing together the best of both. So the DGX system is a suite of solutions that include enterprise-grade orchestration and cluster management, libraries that can accelerate your compute, storage, and network infrastructure, and an operating system optimized for AI workload. For Code IT, it is a tool that includes cluster management, job scheduling, and orchestration as a singular solution. This translates essentially to the core IT folks not needing multiple products or open source tools to manage a DGX cluster. This is a single pane of glass for everything, making their workload a lot more efficient. Base Command also offers reporting so one can see who's using the resource, when they're using it for, and how long they're using it for. So enterprise can get a better understanding of resource consumption later. So if we're moving away from enterprise and we're talking about the examples in Tunisia for an example, currently they're facing an issue where there's more demand than supply for the DGX. So in order to be able to divvy resources for the DGX, they do this. They go in and they look into who's using the resource, how long are they using for, so that they can make sure that everybody gets access to it. Now, when we're talking about developers, Base Command is the software which allows them to build prototypes and eventually evolve them into product-ready models that can be used in AI applications. So the cool factor for them is what they run their jobs. They can take full advantage of multiple GPUs or multiple systems in a cluster, making the underlying infrastructure completely invisible and seamless. On top of NVIDIA's Base Command, you have the NVIDIA AI Enterprise, which is included in every single DGX system and provides platform for AI development. NVIDIA AI Enterprise offers pre-trained models, optimized frameworks, and accelerated data science software libraries. Since we're on the data science software libraries, I will pass the mic over to Torian, who will talk a little bit about how he sees AI infrastructure from his daily work. He will then give us some examples, and then from there we can go into a Q&A, as I'm aware that we have about 15 to 20 minutes, and we want to make sure that the audience gets as many questions as possible. We've also shared these slides with the DSN team, so if anyone needs to refer back to them, feel free to inquire with the DSN team, and I'm sure they'll make it available to you. So I'll pass the mic over to Torian. And Torian, if you need to share some slides, please let us know. We'll end it, and then you can share your slides. So over to you, Torian.
Hey everyone. Give me 1 second while I pull up some things. But if I can get a feed from the crowd, um, what are you almost interested in knowing about on the DSN side? Is it the ML ops? Is it deployment? Is it the hardware deployment or the software deployment? Like what, or the networking aspect? What are your major interests?
So I think this is a in-person element, Torian. So most of them aren't online. So to the DSN team, if you can let us know for
Yeah,
the next part, what would be best for the audience? Like out of everything that Torian mentioned, if you could just drop it in the chat so that he can
or
the rest.
unmute and just say hi.
Okay, thank you.
Uh, well, while you unmute, let me sharing's not turned on. I am not allowed to share, so this is going to be very interesting. Okay. So when it comes to data science, there is a lovely field called ML ops where, we let's take a step back. If you've looked at a data science job posting, there is a there's usually a request of being everything from a sysadministrator all the way to being like a high-end, practitioner. And the truth is that not every data scientist knows how to deploy the exact infrastructure that they need from GCP or Azure on a moment's notice. Um, there is there's a space in between where well, not we, but generally, us as a group, data scientists, want to be really, really good at what we love. That obviously is that opening for ML ops, which allows for other people to be like, hey, listen, I really love the hardware, the infrastructure. I love supporting these teams, and I understand what is necessary to help you get your job done. So, let me know when I get sharing allowed. Okay, great. I got sharing now. So, to help assist with that, we have the big three clouds as well as a deployment guides for Rapids. So what I'm going to do first is I'm going to work through on what it is that you need to look for when deploying to the big three. And then we're going to take a big step back and we're going to go to our deployments guides to talk a little bit about installing locally. Okay. And the reason why we're going to start with with deploying to the big three, and we're going to come back to it, we're going to go full circle, is because having a good understanding of what it takes to actually run some of these, from just ML models or optimizations to ProViz, all the way to, let me take this down, all the way to deploying your LLM. You have to understand you have to understand your GPU itself. The reason why you have to understand about your GPU is because even in the same family, in the same generation of GPUs, some of those GPUs are tuned, and we're going to use that word for a second, tuned to do certain things better than others. It's like a car, right? Everything has an engine, four wheels usually. Um, but you've got trucks, you've got SUVs, you've got little sports cars, and your daily drivers, your grocery getters, as they call them. So what does that mean? That means that let's assume that you've got a V100, right? It was found in the original some of the original DGXs, after the T4s, the second generation DGXs, and we were running it against the RTX 8000 on a spatial algorithm called points and polygon. If you took the RTX 8000, which had more RAM than the V100, which is why we wanted to use it, it was able to complete the job in about 3 minutes, something that took hours or days on a CPU. However, in a V100, it was 30 seconds. And that's because in each GPU, there are these processors inside, which we call the CUDA cores. And there's shader processors, there's tensor processors, and each one of them is optimized to a different floating point. Now, you may not need to know all this detail, but when you deploy LLMs, and you get to the quantized models. You've got your 8-bit, your 4-bit, and there's new research on 1-bit. Um, and some GPUs, especially older GPUs, can't get that low. And some GPUs, like if you were using a P100 versus a P4 versus a P40, the P40s, which is not on this because they don't normally show up, the P40s um, weren't able to get float 16, even though the P4s and the P100s were. So when you're deploying, there's a lot of considerations to get the best out of your hardware, to then allow those that you're supporting to get the best out of their software. So another thing that you want to look at is the amount of video memory or RAM that you have on these cards. The higher it is, obviously, the more you could fit. And that's great. But do you need to get something that has 80 gigabytes Or do you need something just because? Or do you need to get something that has 24 gigabytes or 40 gigabytes? The A100 also comes in 80 gigabyte flavors, but at the time we made this, it was not available. And that's kind of the juggling that you're going to need to do is to understand the best compute performance in terms of morning, in terms of in terms of the actual core die of the GPU, and then marry that with the needs of your teams for the amount of RAM that they actually need to execute. And then, of course, with flops, with the teraflops, you have the amount of this is the speed at which they can process turtle floating points. I believe I optimized this for either 16 or float 32s, and you can almost double them for float 16 and keep going down the line if it is capable for them to go to float 8, float 4 bit or 1 bit. Well, some of them, most of these can't do 1 bit up until here. Now, does anyone have any questions on what I just shared? All right, we're gonna move on. So your CSPs, these are the big three. We made this graphic to just make it easier for people to find and understand what GPUs they're getting per CSP instance, because a lot of them, all you're going to see is G4 or NC12, and you may not understand the differences between them and what they allow. So interestingly enough, if you do in AWS, if you did a P3 and you did a single or a dual GPU, you could get a 16 gigabyte GPU, which might be good for where it needs. But if you needed a 32 gigabyte GPU, you would need to get the P3DN 24X. And those are expensive machines. I've had to do benchmarks where I needed a 32 gigabyte GPU, and this was the only option at the time. So you want to be able to, so what we did was we wanted to be able to map out this landscape between Google Cloud, Azure, and AWS and help ease that choice so that you don't make the wrong ones, because this can be a very interesting mistake, especially as you have to download the data onto here and everything, unless you use S3 buckets, in which case you can connect with AWS, GCP buckets for Google Cloud. Azure has their storage solutions. And then finally, once you have your instances and you know what kind of GPU you want, you know the RAM, you know what kind of speed you're going to be getting. Now you want to be able to deploy either on at scale or on a single machine, right? So you might get like 20 of these P3s if you're going to do a large scale model, or a couple hundred, it doesn't matter. Sorry, on the P5s, I should say, the P5s to do a large LLM training. Or you might just need to just have one of them to do some inferencing. So with one GPU. So we have these tutorials that allow you to deploy, at least for our system rapids, onto these systems in both a single GPU and a multi GPU node. Wait, I'm going to stop sharing for a second. This is a great time for questions, and we're going to go into how that deployment happens.
For the DSN team, since this is a in-person session, it would be great perhaps if one of you could perhaps collect some of the key questions that's coming out of the audience, and then we can answer it that way. Or if anyone has a question in the class, feel free to um, raise your hands or stand up, and then we will make sure that the question is in the chat if we can't hear it. The more questions we get, the better. We want to make this session as interactive as possible.
We'll move on a little bit, but I just want to make sure you can all see the screen. Trust but verify. Fatima, can you see the screen? What I'm showing?
Yes, I can see the screen, Torian.
Sweet. Okay. DSN, you're allowed to unmute if you need to. Okay, so for rapids, right? We're gonna focus tightly on data science right now. Yeah. So we do run benchmarks for the GPUs, and we have created the ways for you to make your own benchmarks, usually in our rapids packages. Um, let me bring up rapids right now. Actually, wait, I don't even need to go there. We have user guides, and we could do benchmark. So we have benchmark capabilities built into some of our packages. If our search
Right.
works. Um, and then you would be, I'll just go to the GitHub. It's easier there. Let me do it this way. So in cuDF, cuML, and cuGraph, you can actually create data sets that are fake but huge. And then you can run your own benchmarks through there. You can also just log in, just fire up a couple of GPUs if you want to do your own performance testing and run a couple of samples on the algorithms that each person is going to use. However, in general, this the page I showed you, um, at least for AWS, for cloud instances, it's pretty consistent, if you know what I mean. Some clouds may have different interconnects, and we can talk a little bit about the interconnects between um, either same GPU, same system, single node, or multi-node. That might be that might be the biggest difference between the three clouds. Okay, so there's like TCP, there's UCX, there's InfiniBand. Those are the interconnects you're going to see between each system. And for the re for and if you since mostly you're going to be deploying a cloud, that's going to be your biggest source of latency, whether or not you enable it or whether or not you can enable it. After, as you go down this list, these GPUs just get faster and more powerful. But when we're talking about deploying on a workstation, that's where you're going to have a little bit more variability because most workstations aren't going to come with a Tesla compute card. They're going to come with a prosumer like A6000 ADA, which is the equivalent of, I believe, the A100. No, the A6000 is the A100. This is the equivalent of the H100, the ADAs. So that's when you really have to look out for that processor discrepancy. Unless you're doing LLMs, in which case just honestly stay down towards the Ampere, Lovelace, and Hopper. If you need something low powered, you want to do Lovelace or the A10s for inferencing. Does that kind of answer your question? Does that answer your question, or do you want me to go into?
I think that does. Thank you very much. So I don't know if you have any other question.
Okay, so let's go to deployment guides. So there's several different ways that you can deploy, right? I'm going to send this in the chat quickly. Um, And in here, you have the ability to do local machines, which is basically the workstation. Cloud, which is what you saw in the previous slides. Oops. Um, and then also how examples you can use, deploying with NIMs. But it's from these two that you're going to probably do the most of your work. The other thing that you can do is use something called AI Workbench, which helps you do not just build on your local machine, deploy to the cloud as you want, or have it do a hybrid based system. And it's really pretty nice. It uses NIMs, which are our microservices that you can uh, basically connect as different kinds of nodes to have your information flow and be processed correctly. So that way you can get the output that you want. Now within for Rapids, you're going to have your local machine. With your local machine, you're going to have a few installation options: Conda, Docker, pip, and WSL2. Conda, WSL2 is a special one. It's not really an installation option. It's just our own, the way to install Rapids on Windows, because Rapids itself and many of these software are based on, are made to be deployed on Unix-based systems. Conda and pip are package managers. Docker is a containerization system. So are NIMs. And even WSL2 is technically a container of Linux with extra accesses available for Windows. I would ask if you're all familiar. Please do write it in the chat. Within our cloud systems, you'll notice that we have ETC, which for Amazon Web, Azure, Google, we have IBM Cloud. You can decide whether or not you're going to do something where you're not really spinning up an instance, you're just working within a predefined instance like SageMaker. Sometimes you're going to need to have that single GPU running or the single node running, and you can do that with EC2. And then you get into the multi-node systems with large clusters. And we have instructions on how to do all of these in here. We test these every release. And we do invite you to, if you find an error with it, or want to have an improvement, we have a GitHub actually that you can go to. Let's just go there. Wow, I should have just had this up. It's called deployment. And here you can, this is a public GitHub that you can make issues, make requests. We want to see what you want to deploy and where you want to deploy. And we tend to do our best to have the team swarm on some of these ideas and after we've roadmapped them. So, as you go forward and you have thoughts and suggestions, we really encourage you to please let us be part of that journey. Where the team is extremely friendly. We love helping. We have the Rapid Slack channel, and you can message us there as well.